Hi everyone, welcome to the video. Today we are going to solve closest number in a binary search tree. So in this question you are given the root of the BST along with the number n, and you have to return the largest number which is either less than or equal to the n. The largest number in the nodes of the BST which is either less than or equal to the n which is given in the input. Okay. But first I will tell you beautiful concept that BST follows binary search concept as its name is. So if the value of n, if the value of n is less than the root, if the value of n is less than the root, we'll have to completely ignore the right subtree and only look out for the element in the left subtree. However, if the value of n is more than the root element, which is the case in example 1, we'll have to completely ignore the left subtree and move towards the right subtree. Since n is 24 over here, which is greater than the root element 5, we'll ignore left subtree and move toward the right subtree. Next element 12. Okay, 12 again is less than the less than the 24. In that case again we'll ignore its, okay, the left subtree of 12 and move toward the right subtree. Okay, next element is 21. 21 is again less than 24. Again we will ignore this 19, the left subtree, and move towards the right. But now 25 is greater than, then we will move back. We cannot move further. Then 21 will be our answer. In example 2, this will tell you the opposite case that n is 24, root is 5. Here, the number which we have to find, n is less than the root. In this case, we will have to completely ignore altogether the right subtree and move towards the left subtree. We'll move to the next node, which is 2. We'll see again 2 is less than the value of n. In this case, we'll ignore the left subtree of the 2, left part of the 2, and move towards the right part. We reach 3. We see whether 3 is less than 4. Yes. Whether can we go further? No. So in this case 3 will be our answer. How we will do it? First of all, this is a very beautiful concept, very easy question, but it is asked many a times in the interviews. So first of all, let's store -1 in the result. So this is the one, result will be the one which we will return at the end. But initially, in order to initialize, I have initialized it -1, which means because all the elements in the binary search tree will be positive. Okay. Now while root, while sorry, while there are elements in the root, while we have elements in the root. Okay, while we have nodes in the BST to traverse. Now, if the again the condition, if the key of the root, if root dot key is greater than n, is root dot key is greater than n. In this case, we'll have to move towards the left subtree. Left subtree. Completely ignore the right subtree. Okay. Else, 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 the root dot key of root, the root element is less than or equal to n. Else, if root element is less than or equal to n, in this case, result will become the current root, the current root, and we will see whether we can go, if we can go towards the right subtree or not. If we can go, we'll move ahead and this result will get updated. If not, this result will remain intact, and at the end we'll come out of the loop when we do not have any further node to visit, and we will return our result. Let's check the efficacy of our solution. As you can see, it did the job pretty effortlessly and in very less time. So I hope you learned this beautiful and small concept. I hope you enjoyed it. Thank you. Have a very nice day.